On 23 March 1967, the Board of Inspection and Survey Guided Missile Trials were formally initiated on the F-4J aircraft at the Naval Missile Center, Point Mugu, California. The overall objective of these BIS trials was to determine the service suitability of the missile control system and other components affecting guided missile performance. The aircraft carries 4 AIM-7D or 7E Sparrow III missiles on Aero 7A launchers mounted in 2 forward and 2 aft fuselage positions. It may also carry 2 Sparrows or 4 Sidewinders on the inboard wing stations. The F-4J aircraft is a 2-place carrier-based twin turbojet all-weather fighter whose primary mission is air-to-air combat and ground attack using both conventional and special externally mounted weapons. Concurrent with the guided missile trials, BIS avionic, armament, and carrier suitability trials were conducted at the Naval Air Test Center, Patuxent River, Maryland. Following completion of the trials at the Naval Missile Center, special weapons trials were conducted at White Sands, New Mexico. The F-4J differs from previous F-4 designs in several areas, most significantly in the incorporation of an improved missile control system, the AWG-10. Through the use of a 1,000-watt average power pulse Doppler radar system with an alternate pulse mode and a missile fire control computer, the AWG-10 provides the F-4J with an all-aspect capability, including down look against low-altitude aircraft. The operation of the AWG-10 can be best understood by comparing it to conventional pulse radar and continuous wave Doppler radar. In normal pulse radar, a pulse is transmitted periodically, and the target's range determined by the elapsed time between transmission of the signal and reception of the target's echo. However, when used against low-altitude targets, the multitude of echoes received from the ground produces a clutter which obscures a low-altitude target signal. Continuous wave Doppler radar overcomes this ground clutter problem by separating the target from the unwanted echoes through the Doppler frequency shift, which results from the relative motion of the target. Continuous wave Doppler, however, has the disadvantage of requiring 2 antennas. Pulse Doppler radar, as used in the AWG-10, combines the advantages of both of these systems. Through the Doppler frequency shift, it separates the target signal from the ground clutter, and through transmitting and receiving during approximately equal periods, 1 antenna can be used. In air-to-air intercept operation, the AWG-10 pulse Doppler mode provides automatic acquisition of head-on aspect 5 square meter targets at a range of 58 nautical miles in vectored search and 39 nautical miles in independent search, regardless of whether the target location requires uplook, co-altitude, or downlook operation. In addition to the pulse Doppler mode, the AWG-10 provides a pulse mode using either conventional or expansion compression techniques as an alternate attack mode for short or long-range mapping, terrain clearance, and air-to-ground ranging. Illumination for the Sparrow III missile is provided in the AWG-10 by an integrated continuous wave transmitter rather than the separate illuminator used in the earlier Aero 1A system. Although the official BIS guided missile trials were conducted between 23 March and 21 June 1967, the aircraft was first flown to the Naval Missile Center in December 1966 for the installation of instrumentation wiring. At that time, the radar had not been installed and the radome contained ballast, which simulated the AWG-10 weight distribution. The aircraft was then flown to Westinghouse Electric Corporation in Baltimore, Maryland, for radar installation. Recording of significant data during the BIS trials was provided through an instrumentation pod installed on the centerline station. The pod contained a 14-track tape recorder, range timing receiver for correlating data with range tracking data, system power supply, and a system programmer. In the aircraft, there were 4 signal conditioning packages, including a pulse code modulator which serve to produce the data in a digital format adaptable to the data reduction equipment. Modification of the wing pylons also enabled telemetry transmission while carrying captive Sidewinder missiles. The BIS guided missile trials were divided generally into the categories of ground tests, captive flights, launch flights, serviceability, and human factors tests. The following description of the program will be presented categorically rather than chronologically. Pit ejection tests of the Aero-7A launcher were conducted on stations 3, 4, 6, and 7 at the Naval Missile Center facility. An earlier attempt to eject at the Miramar Naval Air Station facility had shown the F-4J electrical connection to be incompatible with standard pit ejection wiring used on the F-4B aircraft. The ejection test shown here in slow motion proved that the launchers operate properly and that the necessary voltages for motor fire were provided. In another series of tests, engineers set out to establish the areas potentially hazardous due to the radar microwave radiation. Power density and energy density values were measured at various distances between 10 and 175 feet from the aircraft. For the investigation, 2 modes having the highest average power were used. These were pulse Doppler and pulse mode operating at its maximum duty cycle. The measurements were made with the antenna in a fixed position and scanning in a 120-degree arc. Measurements indicated that the hazard area extended out to 175 feet in the PD mode. However, the F-4J cockpit attenuates the PD signal by 5 dB, and therefore a safe in-flight distance of 22 feet between aircraft has been established for operating in the PD mode with the radar in search. To determine the compatibility of the aircraft, test support equipment, and guided missiles when handled by service personnel, 2 loading tests under 2 different conditions, stateside and simulated tropical, were conducted. In this way, a correlation of the crew's performance under widely different environments could be made. The first test was conducted on the parking strip under ambient temperature, both during daylight and night. Monitoring was done by serviceability inspectors and human factors engineering psychologists. Timing of the task commenced when the crew approached within a wingtip distance of the aircraft and finished when the task was completed. Missiles were loaded on stations 2, 3, 6, and 8, either manually or by using the Aero 64A or the Aero 52A missile loaders. The second test, simulating tropical conditions, began on the evening of 26 May when the aircraft was installed in the environmental chamber for the heat-soak tests. After a 12-hour transition period, the temperature reached 150 degrees Fahrenheit with an 80% relative humidity. This condition was maintained for 24 hours. Then at 0500, 28 May, the temperature was lowered to 90 degrees and the aircraft drenched with a 2-inch-per-hour rain for 2 hours. At the end of this period, the aircraft was examined for deficiencies and water intrusion. It was found that there was water in the APG-59 radome, on the UHF radio and the floor of the RIO cockpit, and on the engine master control panel in the pilot's cockpit. In addition, there was excessive water in the data link compartment. When the inspection had been completed, the cockpits and compartments were resealed and a 1-inch-per-hour rain started. The temperature was 90 degrees Fahrenheit and humidity 80%. The missile loading crew performed this operation under day and night conditions, as in the earlier test. First, an AIM-9B Sidewinder missile was loaded manually on the inboard wing station 8. Then a Sparrow III, AIM-7, was installed on the inboard wing station 2. For this operation, the Aero 64A hoist bar was used. For the loading of the aft port station number 3, the Aero 52A hoist cart was employed. The final station number 6 was then loaded manually. The same ground rules regarding timing were employed as used in the stateside ambient condition test. Unloading of the missiles then was performed in the same order as the loading. After a rest break, the entire test was repeated under nighttime conditions. The aircraft was then returned to the hangar for a complete electrical checkout. This checkout revealed a number of deficiencies, including the APG-59 radar pulse Doppler and pulse displays seriously degraded and numerous no-go indications from the test selector programmer, more commonly known as the built-in test or bit programmer. During the first flight, 31 hours after exposure, several other discrepancies were found. In the 3 months of the F-4J BIS guided missile trials at the Naval Missile Center, 64 flight tests were flown under a variety of operational conditions. To illustrate this phase of the program, a description of one of these flights will be presented. An operation actually begins several weeks or months before the flight with the preparation of a test plan, which is part of the overall program plan. Then, 2 weeks prior to the event, a scheduling meeting is held to inform all involved offices that the test, as well as other operations, is approaching. At this meeting, problems of coordination will be discussed and modification made to the schedule. Present are the representatives of the project office, serviceability, human factors, system evaluation division, air-to-air missile branch, and others. These offices, during the intervening time, will implement the test plan. Approximately 2 hours prior to takeoff time, the missiles are loaded. If the flight is to be a launch, the missiles will be loaded in the revetment area. Otherwise, the captive missiles can be installed at the hangar. As the operation time approaches, pre-flight checkout of the aircraft, the missile control system, and the instrumentation is made by service and contractor personnel. Meanwhile, a pre-flight briefing is underway to ensure that all personnel are familiar with the test plan for the day's operation. The test conductor conducts this briefing, reviewing such items as range time, takeoff time, altitude, target environment, angle of launch if applicable, speed, range, and target aspect. Questions that may arise are also resolved and last-minute problems discussed. At the scheduled time, the aircraft taxis out for takeoff, and the operation begins. The test plan now begins to unfold as the test conductor and others directly involved monitor and control the operation from the control center. Direct voice communication with the aircraft is maintained throughout the flight, while radar position plots of the target and interceptor are shown in real time. At the same time, in the data center, telemetry from the missile, along with all other information, including voice communication, is received and recorded. In any operation, data is critical, and so for the F-4J program, a combination of range and airborne instrumentation was used. Range instrumentation consisted of target control and target telemetry, radar tracking of the interceptor and the target, reception of telemetered information from the missile both before and after launch, and voice communication between control center and the pilot. On the F-4J, the tape recorder in the centerline pod recorded weapon system performance data and elapsed time. Tying all this data together was a range timing signal transmitted to the control center, telemetry stations, and the instrumentation pod of the aircraft. Later, after the operation has been completed and the data reduced, engineers and project personnel analyzed this wealth of information to locate system discrepancies and decide on possible improvements or corrections. This analysis may even show the need for additional operations to answer questions raised by the test. Another source of information was the debriefing session held immediately after the operation, in which the pilot and RIO present verbal reports and test engineers are able to question the operators. The final product of the operation and the analyzed data is the deficiency report, which is reviewed by the Commander, Naval Missile Center. A breakdown of the captive flights conducted during the BIS trials shows the following types of operations and the number of runs in each. Look down, 43 runs. Low co-altitude, 74 runs, of which 25 were in the pulse mode and the remainder in pulse Doppler. Medium co-altitude, 30 runs, with 5 in pulse compression. High co-altitude, 20 runs, with 10 in each mode. In addition, there were 89 electronic countermeasure runs and 38 mutual interference tests. To evaluate missile control system and missile compatibility, 4 AIM-7E and 1 AIM-7D Sparrow III missiles with telemetry systems instead of warheads were launched during the BIS trials. The first launch on 25 April 1967 was in a look-down, high-clutter environment against a closing BQM-34A target augmented to 4 square meters. The missile was an AIM-7E. The target was at an altitude of 200 feet and a speed of 0.62 Mach. At a range of 11 nautical miles, the pilot began to dive to a dive angle of 25 degrees and launched the missile in a head-on aspect at an altitude of 10,000 feet and a speed of 1.1 Mach, resulting in a closing velocity of 1,100 knots. Missile launch range was 6.8 nautical miles with a look-down angle of 12 degrees. The missile guided for 16.9 seconds to a missed distance of 3 feet. Missile control system and missile performance were both satisfactory. A low co-altitude, high clutter environment against a closing target was used in the second launch on 2 May 1967. Again, the target was a BQM-34A augmented to 4.1 square meters, and the missile was an AIM-7E. Target and interceptor altitude was 300 feet with a target speed of 0.55 Mach and an aircraft speed of 0.44 Mach. The launch was made at 22 degrees off head-on with a right aspect angle and a launch range of 6 nautical miles. Closing velocity was 640 knots. The missile guided for 20.7 seconds to a 7-foot miss distance. Missile control system and missile performance were satisfactory. The third launch on May 4, 1967, presented the most exacting environment of the trials, with a look down into a high clutter against a closing target with a large aspect angle. An AIM-7D missile was used. The target, augmented to 3.8 square meters, was flown at an altitude of 2,900 feet and a speed of 0.53 Mach. The pilot pushed over at a range of 6.5 nautical miles to a descent of 30 degrees. Missile launch was made at a 62-degree right aspect angle at an altitude of 7,300 feet and a speed of 0.59 Mach, resulting in a closing velocity of 640 knots. Range was 2.2 nautical miles with a look-down angle of 16 degrees. The missile guided for 8.5 seconds to a direct hit and complete destruction of the target. The fourth launch, conducted on 9 May 1967, was designed to evaluate ripple firing 2 AIM-7E missiles in a high co-altitude, high closing velocity environment against an AQM-37A target augmented to 4 square meters. The missiles were launched in a head-on aspect at an altitude of 45,100 feet and a speed of 1.8 Mach, resulting in a closing velocity of 1,660 knots. The missiles were launched at ranges of 12.8 nautical miles and 11.4 nautical miles. The missiles guided to missed distances of 4.7 and 31.8 feet. In addition to the Sparrow launches, 3 non-instrumented Sidewinder AIM-9B missiles were also fired near the end of the trials. The purpose of these launch tests was to evaluate aircraft missile compatibility. All launches were satisfactory and resulted in direct hits on the Mark 24 flares used as targets. Serviceability and maintainability of the missile control system was monitored throughout the trials, with particular emphasis on the built-in test equipment, the ground maintenance equipment, and the AWM-21 maintenance bench. The bit is a semi-automatic test equipment which provides the RIO with a rapid means of determining the system's effectiveness. The functions programmed into bit permit the selection of a parameter, determination of whether it is acceptable, degraded, or unacceptable, and the reading out of the result. Bit was run periodically during flight and during ground maintenance. In the latter, the TS-2515 AWM-22 umbilical test set was used to simulate missile performance. In addition to monitoring regular maintenance, a detailed test of organization level maintenance was performed using standard procedures and service personnel. Organization level maintenance consisted primarily of substituting line replaceable units called LRUs, which are designed to be interchangeable without tuning or adjustment. At the intermediate maintenance level, the AWM-21 maintenance bench was used to further test the LRUs through a series of fault isolation tests. The APG-59 radar installed on the bench is identical to that being carried in the aircraft, and thus it is possible to perform LRU checkout without aircraft downtime. A fault isolation meter used in conjunction with the bit isolates faulty subcomponents of the LRU and then, after repair, provides the means for retesting the unit. It was found during the trials that there were problems associated with the AWM-21 and built-in test equipment as a whole. The bit mechanization, as demonstrated in the BIS trials, both at the Naval Missile Center and at the Naval Air Test Center, was considered unacceptable by Navy standards. As a result of the BIS trials, the bit equipment will be extensively improved and will be satisfactorily demonstrated prior to Navy acceptance. On 21 June 1967, the F-4J BIS guided missile trials were completed. However, evaluation of the F-4J and the missile control system will be continued in the Navy technical evaluation at the Naval Missile Center. Follow-on testing will also be conducted at the Naval Air Test Center. These subsequent evaluations will be designed to test the modifications made as a result of the BIS trials and evaluate the missile control capability in even greater depth.